Hi, everybody. This is the third video of the AP Statistics Summer Homework Assignment. If you're looking at this video and thinking, hey, you look a lot older now in this video, the other two videos were made 2 years ago. A few people emailed me like yesterday and said, hey, the third video doesn't seem to work right. Somehow YouTube seemed to have deleted the link or something like that. So it's about a week before school in 2025. I've remade this video. And you can just see what I look like after 2 years of aging, right? This video talks about, I made a kind of a whiteboard here, and if you want to maybe pause the video and maybe copy down this chart is called a two-way table, okay? And the idea here is you've got some group of at Sacred Heart, maybe it's the chess club, maybe it's the football team, something like that, and you're asking everybody two questions. You're asking what grade you are, 9, 10, 11, 12, and then you're asking them what is their favorite local bagel place. So BSC stands for Bagel Street Cafe, if you can kind of see that. Posh obviously stands for Posh Bagel. Those two are on Santa Cruz Avenue. And then there's also Izzy's Bagel on California Avenue in Palo Alto. By the way, Izzy's, personal opinion, Izzy's is the right answer to this question. If you don't think Izzy's is the best of those three bagel places, there's only two possibilities. Either you've just never been to Izzy's, because it's down in southern Palo Alto, or you're just wrong, because Izzy's is better. Okay. I've actually done one thing wrong with this two-way table, which is it's always important to label what the things are. So it turns out it's pretty clear what does the 9, 10, 11, 12 mean, but actually I should just write grade over here. Okay. And it's also pretty clear what these things mean up on top, but I'm just going to write up here bagel choice. Okay, it's always important to label your things. Okay, and so this is a two-way table. A two-way table is a new idea. It's the next thing in the list of representations I gave you in the other videos. And this is used for a specific reason where for each individual, you're collecting two different categorical variables. Grade is a categorical variable. Bagel choice is a categorical variable. And the idea is for every individual, you're not just collecting one piece of information, like what language are you taking, you're collecting two pieces of information, which is, in this case, what grade are you and what's your bagel choice, okay? I should mention also that, yes, 9, 10, 11, 12 are, they're numbers, okay? But we still consider them a categorical variable because really it's like freshman, sophomore, junior, senior. Okay, so we're going to answer some questions down here, and I wrote them all down here. I don't think you need to pause the video right now. We're going to kind of answer them as we move forward. So the first thing is, the first question down here says, what percent of students are sophomores? Okay, pretty easy question. Okay, I should have mentioned that for a two-way table, sometimes there's totals listed in the over here, and sometimes there's not. A lot of these questions are going to really rely on the total. So I'm going to add just some other numbers over here representing the totals. 3 plus 1 is 5. I believe I did the math here. This is 15. This is 10. And this is 20. We've got more seniors than whatever this group is. And then going down here, I believe this is 18, 20, and 12. Okay. Those are going to be really useful. And again, sometimes I'm going to give you a two-way table. They'll give you those ahead of time, and sometimes they won't. Okay. So the first question says, what percent of all students are sophomores? Well, that's a pretty easy question. Turns out if you add all these numbers up, there are 60 total students. Is that right? 60? No. No, 50 total students, excuse me. Yeah, 50 total students, my goodness. So out of 50, how many of those students are sophomores? Well, it's this number right here. So 15 out of 50 as a percent is, let me make sure I do this right here. Yes, 30%. Okay. 30%. I'm just making my notes. I can do the math. I just want to make sure that's the case. Okay. Then this next question says, what proportion of all students picked Izzy's? By the way, I know I wrote here percent up here and proportion down here. You're going to see these kind of used very interchangeably in this class. Proportion technically kind of means a fraction or a decimal, and percent obviously means the percent symbol. So if this question number one, if that percent was just changed to proportion, you would just write 0.3, or you could kind of, do 3/10 or something like that. In this case, what proportion of students picked Izzy's? Well, we still have 50 total students, and you can over here, the total column is really useful. 12 of them picked Izzy's, okay? And so that actually reduces down. You can just leave it like that, or I think it's actually 6/25 if you just divide by 2, okay? Okay, sweet. So that's two questions there. Let's go on to the next two questions. And by the way, I've grouped these questions in a way that they're kind of related, which you'll hopefully see in a second here. This question says, what percent are juniors who like posh? Okay. And the idea here is we're actually kind of limiting, we want two criteria to be true. You have to be a junior and you have to like posh. Well, here are the juniors in this row right here. Okay. And where are the people that like posh? It's this number right here. So these three students are the only students who are juniors who like posh. So I'm going to write this as 3. Oh my goodness, this orange pen is hard to read, but it's 3 over 50, if you can read that. And that turns out to be 6% of the students are in that category. Okay. Down here it says what proportion are seniors who don't like Izzy. So again, two criteria have to be true. You have to be a senior and you have to not like Izzy's. Well, these 5 students right here are seniors who like Bagel Street Cafe. These 9 students right here are seniors who like Posh. So if you add those two numbers together, you get 14. These two things right here are the 14 seniors who don't like Izzy. So 14 out of 50. And I think that just reduces down to 7/25. Okay. And again, if you wanted a percent, you would just list it as a percent. Okay. Next two questions. What percent of juniors picked Bagel Street Cafe? Okay. And by the way, these are all the kind of questions that you might be expected to kind of pull out of a two-way table. So this basically means out of all of the juniors, what percent picked Bagel Street Cafe? So you'll notice over here the initial denominators were always out of 50 because these first 4 questions were asking about the total. Here, we're just looking at the juniors. So where are the juniors? Look, there's only 10 juniors. So the denominator over here is going to be 10. Okay, and of those, where are the ones that picked Bagel Street Cafe? Well, these 4 are the only 4 juniors who picked Bagel Street Cafe. So 4 out of the 10 juniors picked Bagel Street Cafe. Okay? And of course, if you just do that as a percent, 4 out of 10 is 40%. Okay. I promise, by the way, in class, I'll write more neatly than I will on this whiteboard that I'm holding in my hand. Okay. Let's look at this next one here. Of all the students who picked Posh, what percentage of them are sophomores? So again, we have a different denominator now. We're not talking about all the juniors. We're not talking about all the students. We're saying just considering those students who picked Posh. So where are the students who picked Posh? Well, it's just these 20 students right here, right? So I'm going to put a 20 on the denominator. Okay, because we're just limiting ourselves to the students who picked Posh. There they are. There's those 20 students. And then out of those 20 students, how many of them are sophomores? Well, it looks like 7. Okay? And I think that actually fraction can't reduce. So we would just leave it like that, or you can convert it to a decimal too. Okay. So these are kind of 6 questions that you might be asked to do for a two-way table. They're pretty typical. Okay. It turns out questions like these kind of have a name, and I grouped them for a very specific reason. Okay. These 2 questions right here are something called a marginal relative, or I'll just do marginal frequency. Okay. Our book calls it marginal relative frequency, but that's okay. The idea is these 2 questions really talked about where if you look at this, the numerator is a number in the margin, meaning it's either a row total or a table total, right? And the denominator is the entire table, right? Okay, questions involving marginal frequency have to do with the total of a row or the total of a column. And again, whether you call it marginal frequency or marginal relative frequency doesn't really matter too much. But the term margin means you're looking for a row total or a table total because that's kind of the numbers in the margin, if that makes sense. Okay? Okay, these questions over here, these 2 are questions involving something called, my pen's really bad here, joint frequency. And a joint frequency question usually has the word or the idea of an and. If you think about these 2 questions, these were not numbers in the margins. These were things where 2 things had to be true, this and that. In this case, it was junior and Posh. In this case, it was senior and doesn't like Izzy. Notice I said it's not always exactly the word and. Okay, you'll notice this second one actually had the word and right there. this question did not technically have the word and, but it certainly was the idea of and, right? Two things had to be true. Okay. And then this last two questions over here are questions that are sometimes called conditional frequency questions. That's the word conditional. Trust me, conditional frequency questions. Conditional frequency questions are questions involving something like given that, where you'll notice those two questions, unlike the first four questions, the denominator was not 50, right? You were limiting yourself to one row or one column. You're basically, for a conditional frequency question, you're asking yourself, not out of all the students, but just out of this subset of students. And usually the denominator will either be, in this case, it was just this row because you were talking about just juniors. And then here it was just this column because you were talking about just people who picked posh. Okay, so the idea with a conditional frequency question is the denominator is either usually a row or a table total question or a table total value. And then you're limiting, you're ignoring, like if this question, you're ignoring everything else in the table except for the junior row. And for this question, you're ignoring everything else for the table except for the posh column. Okay? So those are just terms you're going to have to know, right? Marginal frequency, joint frequency, and conditional frequency. Our book sometimes calls them marginal relative frequency, joint relative frequency. That's not super duper important right there. Okay. I'm going to pause the video and kind of flip over the whiteboard and kind of get ready, but we do want to talk about visually how might you represent this table. Because when you look at this table, so much of AP statistics is about like what's the so what, right? And what you might notice here is, well, like what's the kind of takeaway from this two-way table? Well, there's more seniors than anybody else. That's kind of one thing to notice, right? Posh was the most popularly picked one. That's something else you people notice, right? Sure seem like seniors kind of seem to know what's up, and they're picking Izzy's a little bit more frequently than the freshmen are. So those are kind of some takeaways, but it's kind of hard to look at the numbers. So in a second, we're going to start looking at like a graph of these. Okay, so let me just kind of pause this right now. And okay, so let's talk about how to make a graph of this. There's actually two different types of graphs we can make out of this. This is the first one, and it's called a side-by-side bar graph. Okay, and the idea is pretty simple. Down at the bottom, what I did is I labeled the three different bagel choices: Bagel Street, Posh, and Izzy's. On the y-axis over here, I put frequency. As a reminder, frequency just means number of individuals. So I didn't like the term frequency. I could have labeled it as number of students. And then I just made kind of three sets of 4 bars each representing the total number of students, right? And I made a little key over here that kind of represents what do the kind of color coding mean. Tried to make juniors all blue, kind of. By the way, you can also use colors if you have colors. I figured many of you would not have colors, so I chose kind of not to do that, right? But this is a kind of a side-by-side bar graph. And I'll talk about it. I'll make a couple comments, right? The first is this lets you kind of visually see things in a way that actually you might not for the two-way table itself. You'll see over here, it's kind of striking that the senior bar for Izzy's is just way taller than the other ones. Okay, it's pretty clear over here that actually, oh my goodness, it seems like sophomores and seniors tend to like Posh more than the other grades do, right? And of course, the weightings of the different classes, there's more seniors in this group than there even were freshmen. So the freshman bars all kind of seem low in itself, right? So that this does let you kind of, there's going to be some questions on the homework that ask you kind of the so what do you see? What are some comments you could make? Seniors seem like they prefer Izzy's more. Compared to the other grades, juniors tend to not like Posh, right? The total number of students that like Bagel Street seems to be relatively more equal than the other ones. Those are the kind of comments you're going to make. We're not looking for any kind of analysis or anything else. Just kind of say what you see. Okay. Two other comments before I talk about the other graph. Over here, I wrote frequency. Okay. Again, that just means number of individuals. In this case, it's the number of students. You could have changed this graph to be relative frequency, and then the only difference is this would have been percents on the side, and it would require you to do kind of a lot of division, right? And then you can kind of think, what would the percentages have been? Because there was 50 total students, right? So this would have been, instead of being 5, it would have been 10%, and then this 10 would have been 20%, okay? So that's the first thing. Frequency and relative frequency, just the shapes of the things look the same, but what's on the axis Just kind of the units change, okay? The other big comment I want to make, and I won't show you this, but of course, this is only really one of two side-by-side bar graphs you could make. I kind of arbitrarily put bagel choice down here, and then I made 4 bars representing the grades. I could have done the opposite. Down here, I could have put 9, 10, 11, 12, and then I could have for the freshmen, I could have had 3 bars each representing the 3 bagel choices. That would have also been a side-by-side bar graph, and maybe you would have kind of seen something different or made some different observation. It's a little bit of an art to say kind of which one do you want. Usually if the question says make a side bar graph, what you're going to be doing is they'll kind of tell you which one they're looking for. Like it'll say, put this on the x-axis or something like that. Okay, great. There's one more kind of graph I want to make. I'm going to pause the video and I'll talk about the last kind of graph. Okay, so this is our last kind of visual representation of categorical data. It's called a segmented bar graph. I wrote it right here. And this is what it looks like. Let me kind of break this down a little bit, right? The kind of overarching idea is you're going to take the bars from the bar graph and kind of stack them on. You're going to take these bars and kind of stack them on top of each other and then scale it to 100%. So if you think about it, these 4 bars represent all the people who like Bagel Street Cafe. There were 18 of those students. So if I kind of stack them on top of each other and then scale it up to 100%, I get this column right here, right? And visually, you'll notice that actually this one is taller, right? This one actually ended up being, 6 out of the 18 students, which is a third. So like that kind of represents like a third. And you do that for each of the columns, okay? So again, the key thing with a segmented bar graph is that all the bars are the same height, right? Because it was kind of tough to compare these over here because we kind of like had more seniors, right? Not that many people like Izzy's overall. So this lets us kind of compare the different distributions in a way that makes a lot of sense. So again, every column has to add up to 100%. The y-axis is always relative frequency. Again, a synonym for relative frequency is just percent. And then you can kind of stack the bars on top. And so like, how did I figure out how big this one should have been? Well, if you look back at your actual two-way table, you'll see that only 12 students liked Izzy's. 6 of those 12 students were seniors. 6 out of 12 is 50%. So just this little segment right here should be 50%, right? A segmented bar graph generally is considered the best way to look at categorical variables when you have 2 categorical variables because it lets you make some really striking observations, right? What's the one thing what are some big kind of takeaways here? Well, it turns out you can kind of see there's just not a lot of freshmen because all the white bars tend to be lower, right? Okay, you'll notice that actually the juniors kind of these bars are, well, I wouldn't say they're exactly the same height, but they're kind of the same height, right? Where, as the sophomores really tended to like Posh because that sophomore one tends to be bigger. And of course, when you just look at Izzy's, you'll say, wow, seniors really like Izzy's. In fact, you notice liking Izzy's tends to go up the older you are, maybe because you can actually drive to Palo Alto to California Avenue. But this really lets you kind of make some observations, some kind of so what questions in a way that sometimes this one doesn't, and then sometimes even like the two-way table doesn't as well. So that's the idea of a segmented bar graph, right? And it takes some division to figure it out. Like, I kind of just eyeballed, okay, this was, 3 out of 18. Obviously a computer can really kind of do it for you. A lot of times the College Board will give it to you, but it takes a little division to kind of get this all figured up. And again, the idea is this one right here was 3 out of the 18 students. That's a sixth of the entire column, right? Whereas like this one right here, there were 12 total people that liked Izzy's. This was 6 out of the 12. That's why this particular segment right here is 50%. Okay, so that's a segmented bar graph. There's going to be some questions on the homework that ask you to look at a segmented bar graph and kind of make some observations. I think there's even one question that asks you to, oh my goodness, make a segmented bar graph. Okay, so now that's all the videos for the summer homework, you guys. I will see you in class on that maze day where it's very short time. The homework, again, is not due on that maze day. It's due for the first day of actual class, which is, I believe, on that Friday. So if you're watching this video, today is actually Thursday the week before, so you've got like 8 days to do it. Great. Look forward to seeing you guys and hope your summer ends up well. And thank you, thank you, thank you.